Right now, a fleet of NASA spacecraft are turning their attention to an unusual object speeding through our solar system.
It's not a natural object because we don't see a beautiful tail behind this object the way we see around comet.
One object, three major contradictions, and no clean explanation. 3I Atlas is defying the laws of physics.
That 3I Atlas, this strange interstellar visitor, is not just a comet, not just a frozen rock from another star system, but possibly some kind of alien technology.
It flared up too early, shed metal no comet should carry, and stayed perfectly on course while visibly losing mass.
NASA scientists say it's a comet. It could be alien technology. You heard that right. So, does this mean ET is real?
Scientists have never seen an interstellar object behave this way. Is this just a comet gone wrong? Or is this the first real sign of alien control? The brightness surge that shouldn't exist. If 3I Atlas were just another comet, it should have stayed dim like math predicted. Between early May and early June, its path brought it just a little closer to the sun.
Even closer to the sun, astronomers were astounded to see Comet Lovejoy's tail glowing in extreme ultraviolet light as it approached the sun.
About 1 astronomical unit. Standard physics predicts that brightness should rise gently, maybe by a factor of 1.5. But that's not what happened. Instead, over those same 4 weeks, 3I Atlas brightened by nearly 5 times. And this wasn't a flare or a sudden spike. It was smooth, steady, progressive. Night after night, telescopes like TESS, ZTF, and the ATLAS survey in Chile all recorded the same thing. A slow but undeniable surge in light, strong enough to light up the crowded sky near the galactic center. Astronomers checked for the usual problems. Maybe the object was crossing a star field, or the signal got scrambled by background clutter, or maybe the telescope's calibration was off. But the data held up across observatories and continents. When they stacked the frames, removed the background noise, and corrected for every variable, the light curve still showed the same impossible rise. 3I Atlas was glowing like a comet, 10 times closer to the sun.
It's now passing by Mars in September and will reach the sun for its closest approach on October 29th.
That's not supposed to happen, especially not at 6 astronomical units out, a region where solar heat can't even wake up water ice. The coma was already visible, and worse, it was growing. Measurements showed the cross-section of that dust cloud expanded from 300 square kilometers in early May to over 1,700 by July. That's not a glitch. That's activity. Comets only do this when something triggers them, usually sunlight. But at this distance, sunlight doesn't do much. That means 3I Atlas was active for a reason scientists still can't explain. So they ran the models again, compared it to field stars, used synthetic solar analogs. They trimmed the error bars so tight that randomness was off the table. But the curve didn't just rise, it followed a perfect arc. Nothing about this object's behavior fits the playbook. A 6-fold brightness surge, a green glow, and a tail pointing the wrong way, all happening at once. That shouldn't be possible. So what exactly triggered all of this? The comet mystery. When astronomers looked closer at the glowing cloud around 3I Atlas, they found something that pushed the mystery even further.
All there is to know about NASA's latest observations of comet 3I Atlas.
Using spectrographs tuned to the faintest traces of light, they scanned the coma, expecting the usual chemical mix. What they found was metal, but it was not the kind of metal they were expecting. Nickel lines showed up clear as day. That part wasn't surprising. Nickel is common in comets. But something was missing. There was no iron, not a trace. In space, nickel and iron almost always travel together. They're built in the same kinds of stars, shaped by the same explosions, locked into the same dusty rocks. The Sun itself has 18 atoms of iron for every nickel. Even the most metal-rich comets only ever show nickel slightly ahead. But 3I Atlas wasn't slightly ahead. The nickel-to-iron ratio was off the charts. 15-1, maybe even 50. That's not just strange. That's unprecedented. The team at the Very Large Telescope in Chile ran the numbers again, then again. They recalibrated, reprocessed, rechecked everything. They stacked exposures, probed for hidden blends, and still came up with nothing. Nickel was there, iron was not. Some scientists tried to explain it with chemistry.
Astronomers recorded 3I Atlas in ultraviolet, blue, red, and near-infrared light.
Maybe the nickel came from a fragile molecule that broke apart more easily, something like nickel carbonyl. But iron carbonyl isn't as likely to form or survive in space, and that didn't explain the complete absence of iron lines. Others suggested it might be a fluke of how the comet formed. Maybe some weird process that filtered metals during birth. But a few voices started asking a different kind of question. What if this wasn't a natural imbalance, but rather the residue of something built? Nickel-rich alloys are common in engineering, especially in machines designed to resist heat or pressure. Engines, turbines, spacecraft shells, all of them use nickel-heavy metals. The idea wasn't proven. There were no direct signs of fuel or exhaust, no telltale propellant lines. This wasn't just a chemical signature. It was a fingerprint, one that pointed away from nature and toward something harder to explain. If this were a comet, it would be the strangest one ever seen. And if it isn't, then the nickel might be the first physical clue that 3I Atlas was made, not born. And that's when scientists started to consider the possibility of this interstellar object being under alien control. Alien control. If 3I Atlas is under alien control, the clearest sign might not be in its brightness or chemistry. It might be in how it moves. Because the one thing no one can explain is why this object refuses to drift. By July, astronomers had collected enough images to map its exact path. What they found didn't match any known comet. The object was active, visibly shedding gas and dust, but drifting just barely.
As insolation ramps up, volatile ices sublimate faster, dragging dust off the surface to form a brighter, broader coma and tail.
About 1 to 1.5 kilometers per day. That number may sound small, but in comet physics, it's almost nothing. At this point, the idea of control becomes more than just a theory. It becomes a serious possibility. Comets with visible tails behave like rockets. The gas they release acts as thrust, pushing them off course in ways that can be measured down to fractions of a kilometer. Astronomers call this non-gravitational acceleration, and for decades, it's helped them model comet paths with precision. The more active the comet, the more its orbit curves. 3I Atlas had a distinct motion followed gravity so cleanly that even the most sensitive measurements showed no real deviation. It behaved like a solid, inert rock, despite throwing off a visible coma and jets of vapor. That doesn't just break expectations, it breaks physics. The last interstellar comet, Borisov, showed a drift of nearly 100 kilometers per day. That's what happens when gas pushes back. Even small outbursts can tilt a comet's course, but 3I Atlas stayed locked in place. Models that accounted for everything – mass loss, outflow pressure, nucleus size, shape, spin – still couldn't explain the stillness. The only way to make the math work was to assume the object was far more massive than it appeared, something the size of a small moon, dense enough that gas jets couldn't move it, but photometry data shut that idea down. The brightness doesn't match. The coma doesn't match. The size doesn't match. So if it's not mass holding it steady, what is? It has to a system that cancels out the natural drift of activity. one that keeps the object on track even as dust and gas pour off its surface. That's not something a comet does. That's something a craft does. And if this is a craft, then it's doing exactly what a long-range probe would be expected to do: adjust for internal thrust, hold trajectory, and suppress drift without broadcasting its presence. No one has found direct evidence of propulsion, no heat signature or trailing exhaust. But this kind of motion may be the cleanest signature of intent we've ever seen. And for scientists now taking the alien theory seriously, this might be the strongest piece of evidence yet. Scientists react. In science, words like control and alien don't get thrown around lightly. Most astronomers work their entire lives without entertaining those ideas. But 3I Atlas is forcing a few of them to reconsider. The first thing to break wasn't the data, it was the silence. As soon as the trajectory and brightness reports were shared publicly, researchers started posting their own follow-ups. Light curves, coma measurements, orbit simulations, each one backed up the strange numbers. Among those watching closely was Dr. Avi Loeb.
Harvard professor Avi Loeb says aspects of these images, including the brightness around the object and its unusual trajectory, suggests it's not natural.
A Harvard astrophysicist known for his work on interstellar objects. Years ago, he became one of the first scientists to suggest that Oumuamua.
Instead, I can tell you that when there was a colloquium about Oumuamua, this strange object that was discovered 2017,
the first confirmed object from outside the solar system might not be natural. His reasoning was simple. The data didn't match any known comet or asteroid. It was doing things no rock should do. And now, with 3I Atlas, he sees something familiar. According to Loeb, if an object shows signs of maneuvering, symmetry, or engineered material, it deserves investigation. Not belief, not headlines, just honest, open analysis. That's all. The data alone should guide the thinking. And right now, that data is strange enough to ask questions no one expected to ask. He's not alone. The Galileo Project, a research effort he leads, was launched to gather evidence of non-natural objects, not signals or messages, but physical materials. The team includes dozens of scientists and engineers who are using telescopes, lab tools, and AI to study sky anomalies without assuming what they are. The goal is not to prove aliens, it's to make room for the possibility that some things flying through space weren't formed by chance. Even outside the Galileo Project, researchers are starting to shift their language. In recent papers and interviews, terms like non-gravitational forces and unusual mass-to-light ratio have started appearing more often. These aren't dramatic terms, but they hint at something deeper, the understanding that 3I Atlas is not behaving like any known object, especially when compared to the other two interstellar objects, Oumuamua and Borisov. A pattern across the stars. An object from outside the solar system flew past Earth and no one saw it coming. It wasn't until it was already on its way out that astronomers noticed its strange path and sudden acceleration. They named it Oumuamua. At first, they thought it was a comet, but there was no tail, no dust, no gas.
It had a very funny shape. It's shaped like a cigar. You know, it's maybe 5 or 10 times as long as it is across.
Just a sharp, silent turn near the sun, and a burst of speed that didn't come from anything visible. 2 years later came Borisov. This one looked more familiar. It had a coma, a tail, and behaved like a classic comet. It lost mass. It curved off its expected path. Everything made sense. The drift lined up with how fast it was shedding gas. The chemistry was predictable. Borisov didn't break the rules. It followed them. Then came 3I Atlas, and suddenly the pattern snapped again. This time, the object was active like Borisov. It had a bright coma and a visible tail. But its motion didn't match. It barely drifted. Despite venting gas and glowing across telescopes worldwide, its trajectory stayed locked, following gravity like a dead rock. The math didn't work. The light said it was alive. The path said it wasn't. Stacking the numbers side by side makes the contradiction clear. Oumuamua had no visible activity, but veered sharply, with a drift of over 37,000 kilometers. Borisov had normal outgassing and drifted close to 100 kilometers per day, exactly what science expected.
This was a really dramatic difference from what had been seen previously.
3I Atlas has obvious activity, but drifts only about 1 kilometer per day, far too small for the kind of coma it displays. If you plot them on a graph, it looks like a set of opposites. One moves without a tail, one drifts because of its tail. One has a tail but stays still. No model explains all three. That's the point. These objects aren't lining up with comet behavior, they're breaking it, each in a different way. Even their shapes don't follow the rules. Oumuamua spun on its axis 3 times per day and reflected light in strange pulses. It might have been cigar-shaped, or pancake-flat, or something in between. We never got a clear look. Borisov showed the usual blur of dust. 3I Atlas is harder to resolve, but early data suggests a solid core, big enough to shine, but not massive enough to explain its stillness. If they were just random visitors, the odds of this much weirdness happening back-to-back are almost zero. Astronomers used to treat interstellar objects like once-in-a-lifetime chances. But if Oumuamua, Borisov, and 3I Atlas are any clue, the universe isn't just sending us rocks. It's sending something very alien. The more complete the data got, the less sense the object made. And soon, even the experts couldn't ignore what the numbers were pointing toward. The amateurs who caught what machines missed. The first official alert about 3I Atlas came from a professional survey.
3I Atlas, a third ever interstellar object observed from Earth, currently racing through our solar system.
But the real story started weeks earlier, buried in data no one had flagged. It was not a scientist who found the first sign. It was an amateur, staring at public images long after midnight, looking for something out of place. Between May and July, 3I Atlas appeared in images taken by the TESS satellite. The object moved slowly across a thick backdrop of stars near the galactic center, a region packed with noise and false signals. The glow was too faint and too subtle to trip automatic systems, so no alerts went out. The object kept moving, night after night, uncaught. Then, in early July, the ATLAS observatory flagged the object's unusual brightness. Professional teams scrambled, but by the time they caught up, weeks of activity had already been missed. Skywatchers from across the world pulled out old image stacks. They checked ZTF, Pan-STARRS, and TESS archives. Some even dug into images taken from their own backyard setups. They weren't looking for perfection, just a trail, just a spark. And slowly, the trail came together. Each new detection filled a hole in the timeline. The brightening curve sharpened. The motion path tightened. Together, amateurs and professionals stitched a full picture from dozens of tiny pieces. In Pretoria, an observer flagged a shift in surface brightness from early June. In Perth, another confirmed it using open-source software and sky subtraction tools. From Chile to Canada, images were reprocessed and calibrated. The difference this time was speed. In the past, objects like Oumuamua were spotted late.
Oumuamua is the first visitor from interstellar space that we have ever confirmed moved through our solar system.
By the time the data came together, they were already gone. But 3I Atlas was still inbound. And this time, the signal wasn't slipping away. Without these volunteers, the early light curve would have stayed incomplete. The coma activity would have seemed more sudden, more random. But now, the record was clean. The brightening was not a burst. It was a controlled, progressive change that started long before anyone was watching. And it was visible, if you knew where to look. Once the full picture came into focus, it raised a possibility no one could ignore. This object was behaving like something with a mission. The light, the movement, the chemistry, none of it matched known physics. And as more data rolled in, the alien control theory stopped sounding ridiculous.
NASA scientists say it's a comet. It could be alien technology. You heard that right. So, does this mean ET is real?
It started sounding like the only thing that made sense. By this point, the patterns are clear. 3I Atlas lights up too early, throws out strange metals, moves like a rock, but breathes like a comet. It doesn't match anything in the comet textbook, and yet all the numbers have been double-checked, cross-matched, and confirmed. This is not a fluke. So, the question left behind is the one no one wants to say out loud. Is it being steered? Astronomers have asked it before. They asked it with Oumuamua, when the object showed acceleration without a tail. They asked it again with 3I Atlas, when the brightness rose too fast and the motion stayed too clean. The difference now is that they are no longer whispering. Control does not have to mean blinking lights or alien pilots. In physics, control can mean correction, something that offsets the push of gas.
This chemical often appears in the coma, the cloud of gas and dust that surrounds a comet's core.
Something that stabilizes a body against drift. It could be internal mass movement, surface dampeners, or a shape that redirects pressure. These are not science fiction ideas. They are engineering concepts, real, mechanical systems that real machines use. The lack of non-gravitational acceleration is the strongest clue. Even small comets with weak jets still drift. 3I Atlas shows a coma, a tail, even jets, but the body doesn't respond. That would be like a balloon releasing air but staying still. The only way to cancel that force would be to balance it, but there is no evidence of rotation strong enough to do that. No secondary jets, no shadowed vents or offset plumes, just activity without reaction, motion without pushback. Then there is the metal, nickel without iron, high production rates, stable ratios, and no matching spectrum for the partner element that should be there. Some researchers suggested exotic geology. Others floated thermal processes or comet birth anomalies. But so far, no theory accounts for both the chemistry and the motion. They stay disconnected. Some scientists have called for caution. The universe is vast. Rare combinations happen. But rare is not the same as impossible. And that is the problem. If this were one anomaly, maybe it could be explained away. But it is not one thing. It is all the things. The light, the mass, the metals, the path. That leaves a narrow window. Either we are watching the strangest natural object in modern astronomy, or we are watching something built to appear that way. What happens next? Most interstellar objects are already gone by the time we know what they were. Oumuamua was already escaping when the alarms went off. Borisov came fast and left faster. But 3I Atlas is still inbound, which means this time we have a chance. From Hawaii to Chile, from Spain to South Africa, from backyard setups to national observatories, everyone is watching, tracking, and searching for signs that might change the story forever. If this object's motion is controlled, then 3I Atlas may not be a comet at all. Because if this is the first time humanity has caught a non-natural object entering our solar system and staying long enough to study, then every image, every spectrum, every line of code might be recording the first clear sign of alien control.